like to thank obviously Fabio Ciucci for letting me doing this stream, and also send my hellos to him. Um, he was very kind with me in letting me doing this stream. As I always say, please subscribe to our YouTube channel and like our videos. Follow us on Twitter, Instagram, and Twitch, of course, here. I appreciate all those that follow me. Like our Facebook page, and as I said, our YouTube videos, and join us on Facebook groups, on our Facebook groups and Discord. You can see all the links, as always, in the top right hand corner. It's like a standard way. It's always my way of starting the stream. So last time we finished in lesson 5b, okay, and now we're going to start, and that was horizontal scroll, and now we are going to start vertical scroll. Vertical scroll is done a bit different than what some of you might know, or how you know it, maybe on the Commodore 64. But just because it's different doesn't mean it is difficult. Okay, it's just a different way of thinking more than anything else. Also, please note, I'm showing the book. I know it's in Italian, and I know that most of you will not, I mean, it's an English thing, you will not understand the book, of course, you will not understand. But what is interesting is when I highlight these in pink or violet or whatever it is, depends how you see it, how your monitor is set up in colors. The diagrams and the code you should be able to follow. So there is no excuse for, just because it's an Italian book, you cannot follow the code. The code is the same. There's no language, machine language. So that's what we are learning, and that's what you should be able to understand. The rest, I'm saying it in words, so you do not need to read the book. You are hearing me doing the translation of the book, so don't be discouraged because the book is in Italian. I felt that some people got discouraged because the book, but to be honest, what's the important thing is not reading the book, it's understanding the code. So yeah. Please note also, if you're on Facebook, you are at a disadvantage. You are 20 seconds delayed, and you are also the quality of the stream is not as good as that of Twitch. Besides the fact that any links that I share, you'll not be able to see them. So, a vertical scroll. So, vertical scroll. Imagine, let's say, a window. Okay. Let's say on a piece of paper, and which has got lines on it, the piece of paper, and you're seeing a window of this piece of paper. If you move the window up, okay, or let's say move the window down, let's put it this way, what was on the top vanishes, and what was on the bottom not being shown comes in. No, so that's a vertical scroll. And the same thing, if you move it upwards, what was at the bottom vanishes, and what was on top comes in. So it's quite a simple method of how to scroll on the Amiga, and that's basically it. Is you're moving your window up and down, basically. As you can see here, so let's say we have this piece of paper, and this is our window, and the piece of paper has got these lines 1 to 5. If we move it down, what happens? Number 1 vanishes and number 6 comes in. So that's all there is in terms of how it works. It's just the method is different than maybe what you are used in the Commodore 64. So the other thing is that you need to know is that from here, from this corner to this corner is 320 pixels. 320 division by 8 to make it bytes is 40 bytes. So there are 40 bytes from here to here, right? And of course, there are 256, if we're talking PAL, 256 lines of pixels, of okay, vertical lines on top of each other. Also, if we had a resolution of the high res of the Amiga, the 640 by 256, let's say, then instead of 40 bytes, we have 80 bytes. Those are the magic numbers that you need to remember in a way, so that you can scroll the screen, or which comes useful on the screen, as you will see later on from what I'm saying. Okay, so here he's continued to showing in the book. Okay, okay, just I'm going to go a bit up. You can see that the letter A has got a blank line on top. Okay, so there's a dotted line on top of it, which is shame. It should have been put on the same page, but it's not, to be visible. So imagine if you scroll this up, so that line is going to vanish and the new line comes in at the bottom. That's basically it. Okay, and the same thing if we do the opposite. So there was one line, and if we scroll it down, the one at the bottom vanishes. Okay, this line vanishes. Okay, and we get a new one from top. That's mainly it for vertical scroll. However, I have done a small diagram just to make you aware what's really going to happen. So we have here we have a height of 256 pixels, okay, or 256 lines, okay, and remember this is 40 bytes, okay, and this is our window, okay, the one in black, and this is what's below the window, and this is what's above the window, okay. These dots represent pixels, okay, and imagine a whole line of them with 320, okay, and imagine 256 of them on top of each other here. So I marked 0, 1, 2, 3, okay, so because we start from 0, and then it's 252, 253, 254, 255 down below. Now, also note that there are other pixels that we are not seeing just below the window and on top of the window, and we have set the bitplane pointer, okay, to point to here, okay, where the 0 is. So if we change the bitplane pointer by adding 40, what happens? We skip this raster line, okay, where the 0 dot is, and we move into line number 1. So we point it, okay, the bitplane pointer, instead of 0 we point it to 1. What happens is, okay, this will shift the screen one down, and what was in here will be shown, okay. So this pixel will become 254, okay, on raster line 254, and this one where I'm pointing right now, that will become 255. That's basically it. So we are shifting the bitplane pointer by adding 40 bytes to it to scroll down. To scroll up, we are shifting minus 40, okay, to see what's up. That is all. That is what's happening. We are just updating the bitplane pointer either with plus 40 or minus 40. Simple as that. And we will scroll 1 pixel up, okay, or we will scroll 1 pixel down. Depends how we do, whether we do a plus or minus 40. So having said that, Um, okay, we can go and do example number. Um, we did, because I forgot already. B, we're going to do C. Okay, 5C. Okay, this is all. I'm just checking through my notes right now, but I do not see anything else that I missed out from what I had to say. Um, of course, if we are sorry, the message came in. If if um, if we have a 640 screen, then we do plus 80 or minus 80. Okay, minus 80 bytes, I mean, or plus 80 bytes to scroll up and down. Let's do example number 1, 5C. Okay, which I have loaded. I'm going to assemble it. I will explain it in a minute. So the image is not perfect. Okay, what you see in the Amiga, it could have been smooth and made better. The colors could have been made better, etc. I just needed something to convert it, because as you know, as I said, the book had an issue when they converted the codes, the images into floppies, and when they uploaded things, because they use the star in the file name, and as you know, DOS does not like it, the star. However, this plus or minus 30 pixels on top, so the image, okay, let me try to stop it. Okay, I try to stop it as much as possible. So this is a 320 by 256 image, okay, on the Amiga. However, because we're scrolling up or down the image, and I made them intentionally black and white, okay, the images, I made the image intentionally having a top part black and the top part white, so that you can see it. So this one is the black part, okay, and now you're going to see the white part. Okay, these are added parts to the image, okay, which when we scroll is what comes in, so that you can see that the image is 312 by 256, but actually I edit by doing 40 times 30. Okay, so 40 per line times 30, which is 30 pixels, okay, of bytes at the where we store the image, which I'm going to show it in a minute. So if you let me show you what I mean. Okay, so this is the image that we are using. Okay, and here, okay, define constant block, okay, of 40 times 30, so 40 per line, 40 bytes times 30. So I'm doing it 30 times 40. That creates on top of the image um, um, a block of 30 of 30 of 30 pixels, not pixels, so 320 by 30 height. Okay, and same at the bottom. Okay, so 40 bytes by 30. The 30 is the height, so it's 30 pixels height, basically height. So that is why you see the white and the black. Now, if we pass to the code, so this is the part that you need to understand. I mean, you need to understand the code more than anything else. Okay, but in this chapter, okay, there is only one routine. I'm telling you, there is only one routine that was introduced. The other routines were all covered in chapters 3 and 4. So to be fair, there isn't anything that I should be explaining, but I will still explain parts of the code just to make you understand what we are doing. Okay, So the first part is always the same, the initialization part of where we kill the system and we set up our copper. We get the copper system copper list where it is, and we store it. Then we set up our bit planes. This is the only routine introduced in this chapter. Trust me, the others are all routines from the previous chapter. This routine is manipulated or used more than once in different ways, but it's always the same routine. And this is what I like about the book. The book was written in a certain way that you advance step by step, and by reusing the same code and achieving different things using the same code. So there is some thought behind it, and I have to appreciate what Fabio did. And for his he was quite thoughtful about this. So then we have our routine, okay, which is here. This is the routine that we call, okay, and then we have the closure of our program, which is restoring back the OS and going back to the system. Okay, now this is the routine that we've seen several times, okay, in previous chapter, where he uses a flag, and according to the flag he moves something up or down, or move it left or right. It's always the same, it's just applied on different things, but always the same routine, whether we have plus or minus. So you can see he's doing a sub, okay, so subtraction, so this is minus 40, and here he's doing addition plus 40. So this one we're scrolling because we're scrolling down, and this one we're scrolling up because we are doing a minus 40. Okay, so that's all it does. And here this 40 times 3, remember what I showed you earlier, is the size. Have we reached the last pixel line? Okay, the last line. If we reach the last line, then there is no need to continue. This routine, okay, calls the routine to update the bit plane pointer, which is, if you notice, look at the code here, okay, it's the same routine that we have here. Look how it starts. When it initializes, it sets the bit plane pointers for the first time. Okay, it's the same routine, nothing changed. Repeat it down here so that you understand better. He could have used one routine for that. Okay, he didn't do that, but he could have eliminated that routine up there and just called this one. But he didn't do that. But it's the same one. Nothing changes. It's the same routine that I explained in the beginning of the chapter of how to update the bit plane pointers for the Amiga. Nothing else. And this routine, we've seen it in chapter 3, we've seen it in chapter 4 of a flag, having a flag, which is this flag, okay? Sueju means up and down, okay? Sueju means up and down. Of moving something. It can be left or right, up or down, it doesn't matter. It's the same routine. Just applied. This one is applied on the bit plane pointers, and you can see it because what he loads the first thing on this routine is the bit plane pointers. It could have been done on the colors, it could have been done on anything. Whatever you upload here is what you are working on. That's the only thing, and we should be able to see it in the code. Somewhere in the code where the bit plane, here are the bit plane pointers, and he is updating these. Okay, so that's what he has loaded, nothing else. And as you see, I have a picture and the 30 pixels before it and after it, and that's how much we are scrolling. So nothing really out of this world when it comes to the code that you've seen several times. Um, and I do not think I need to explain it again, except I mention it and I'm saying what we did, but nothing else. Now, the code continues. Okay, so we are here, and I need to do, okay, 5C2. This is something that I edit extra. So we are in 5C, actually 5C1. And now, what have I done here? It's the same thing as before. Nothing changed in terms of code. The image changed, and this time I made sure that the background, okay, is black, and that the top and bottom, okay, of the scroll of the image, the 30 that we add, okay, 30 at the top and 30 at the bottom, are black also. That is all, and you can see it by so there you go. That's 30 at the top and 30 at the bottom. This is our image, okay, and these are the colors of the image, okay. You can see the shades of yellow. You can see it because I'm only using red and green, so shades of yellow, okay. And where you see FF, that is full yellow, okay, and we can change it to whatever we like. For example, I just made sure that we are using everywhere black where it is background. So nothing else in terms of code. Most people, okay, you guys need to have the book to follow it, okay. If you don't have the book, I mean, when I say the code more than the book, you need to have the code to follow what is being done and try to assemble it, try to play with it and see what happens. Don't get discouraged because comments are in Italian or whatever. It's whatever it's in those comments, I just said it in words, because I'm making sure that whatever he says, I'm saying it. So instead of having it written in English, I'm saying it in words, doing the translation live to you guys. Okay, so let me check where are with the book, because I think there is more than one example that I need to do right now. So the 5C, 5D, and 5D2, I need to do all those. And actually there are more to them than uh, than what the book says there. So I did 5C, and then I do 5C1B. So this one, okay, I took, later on we're going to see a different example using this, but I took the same copper bar, okay, and I changed, remember there was that yellow, that colorish yellow, I changed it and I made sure that those, I replaced them with that copper bar when it goes up and down on the first letter Amiga. Okay, I'm scrolling it a bit too high, but yeah, that's basically it. It's nothing nothing extra, and I'm going to show you the copper. So the code remains the same, nothing changed in the code, but what was added is this, okay. This is the colors that you see changing behind the on the color where we had yellow. And as you can see, we are saying here, so the color here becomes 110, 1E becomes 210, 210, yeah, 182 becomes 221, and it continues like that. Okay, so it's just colors. And here, this is the line that we wait for. Here is the colors that we change, then the line again, and it continues. So you can see here we are skipping 2 lines between this one and this one. Here we are skipping another 2 lines. Here we are skipping another 2 lines, 2 lines, 2 lines, 2 lines. I don't think it's uniform. 2 lines, 2 lines, 2 lines. I forgot. So far it's always 2 lines. 6E70. Yeah, 2 lines, 2 lines. So it's always 2 lines. I thought I did different, but yeah, it's always 2 lines. So let's run it again. Yeah, it is 2 lines. It just doesn't look like, but yeah. That's basically it. So basically I just added that copy list, okay, at a certain point on the screen so that the color, the logo takes that color, nothing else. It is, how to say, it's quite simple to do things on on the Amiga if you think about it, and you will see soon how easy it is to create a demo effect that you've seen several times in demos, especially in the beginning ones when demos were still not advanced. This trick was used several times. I am, so we did 5C1, we do 5C2. Okay, so I did several ones here. When it comes to C, here what I did is the same example, okay, that we had before, but to show that actually I have 30, those define constant block where I had 30, okay, 40 times 30, the 30 height basically. I am showing them by having a pattern at the end of the define constant block of so that it shows with different color, and I'm going to show it to you. So this is to help you out, okay? These were not part in the book. So you can see here I defined the block instead of zeros, I defined it with OF, and the other one I did it the opposite, F0, okay? And that is how I'm showing, and that's why there are 2 shades of yellow, to show different, to show exactly what's happening. So now 5C3. Now what I did here is, that was a 3-bit plain image, no? So what I did, I said to the computer, instead of having displaying a 3-bit plain image, let's have it as a 1-bit plain. And so the image became, that was 3-bit planes, became a very tall one, okay, of ones and zeros, and like that I can show a full screen scrolling. So I'm just using a trick. I changed it from 3-bit planes to 1 so that I can show a smooth scroll on the Amiga of three screens, 256 by sorry, 320 by 256 times 3, whatever that is, 7 752, I think, no, 752 or 712, whatever, lines. Okay, so that is what's happening here. So, and besides that, I even added the 30 at the top and 30 at the bottom, at the 30 pixels height. You can see it coming up, and you can see it when it goes down, that coming down also the last part, in terms of you see. So imagine this was a shoot 'em up, okay, and you're scrolling the screen. This is how it will scroll, whether it's going up or going down, and how you have to do it. So it's quite easy, just by updating the pointer plus 40 and minus 40, the routine that I mentioned earlier. So we did 53C, 5C underscore 4. So here the same routine, but having those colors behind. I know that it's not so clear, but the colors are showing behind the logo. So imagine everything black and you have something scrolling, something showing behind. It's an effect which I'm using. And here is the old image, the first image that we saw with the 30 on top and 30 at the bottom. But look where the colors are. The colors are behind the image. Of course, they took the color. If you notice here, it was here, the color of here became transparent, and now we are showing those in there. But this is to show you how easy it is on the Amiga to change colors. And even though we are limited with 32 colors, in this case 8 colors, we are showing more than 8 colors on the screen. So that's big advantage, no? I think we did we do them all? Yeah, we did them all, no? For BS, I did it, I think. Yeah, it's the same one. Okay, so now we start the next one, which is 5D S. Okay, and now we have, this is in the book now. So this is the same image that we had before. Okay, I'm going to help you out a bit so that you see it better. I'm going to switch my things on the screen. What is happening here is very simple. So here we have a vertical scroll and a horizontal scroll. What do I mean by that? Remember, the first example was shifting pixels from 0 to 15 on and making a horizontal scroll using the register. But now we are shifting from 0 to 15, but also scrolling it up and down. So it's the same routines that we saw before, but combined. Okay, and I am going to show you in the book now, because this is in the book. So 53C we saw, 54, 5C 1B we saw. This is the routine of, is it 5D? 5D. Okay, so here is always the usual start. Okay, and then the closure of it, and as always in the middle we have the call to our routine, which is, where is the call to our routine? Move copper. Okay, movie copper. Oh, okay, so let me see that I am still okay. Yeah, now notice, okay, this is the routine that we had in, I don't know, 5B. I think it's in 5B, when he moved this screen left and right, and then we have the routine that moves the screen up and down. So this is actually the routine that moves the screen up and down. You see the plus 40, the minus 40 and plus 40, same routine that we covered earlier. Okay, and this is the routine that updates the bit plane pointers when going up and down. So I should have made maybe this one in different color, but because it's going up or down, I just made it the same color. But there are two routines here. This part that updates the bit plane pointer, and this part that moves the pointer up and down. And here is the routine that we did in 5b, okay, of shifting the pixels by here we are adding 1 to each to it, so we're shifting it by 1 pixel. If we start from 0, then we get 1 1, then we get 2 2, then we get 3 3. Remember, it's odd and even bit planes, so we need to apply it for our on the register. Let's find the register. So I was saying he is so if I find Miocon 1, okay, here Miocon 1, you see this is what we are updating. Remember, this is the BPL con 1, where we tell it how much we shift the screen, how many pixels we shift the screen on the horizontal position. Let's say that. So yeah, we are doing the shift and at the same time scrolling. So I'm going to show it again. Nothing changed, same routine, just different effect. Something that, you know what, I disabled the screen for you guys to see it, but I didn't update OBS so that you can see the full screen. That's funny of me, but yeah. So like that you should be able to, you should see what's happening. So we are shifting left and right by maximum 15 pixels, okay, but we are shifting pixel by pixel to the left or to the right, and then when we arrive at 15 we decrement. Basically we start, if we are at 15, 14, 13, and at the same time we are scrolling up and down. So like that it gives the effect that it is a bit like bouncing the logo, although to be exact it has to scroll till the end of the screen to make it really bouncing, but we'll come to that later. For now it's more than enough to see that. Okay, so we did 5D. Let's do 5D2. So this one, you see the image, always say image, but when it goes onto the copper bar, okay, it's like it wraps around the copper bar. You can see it wrapping. You can see the letter M or I wrapping around the copper bar, so it's more visible. Maybe you can see it also at the bottom, where the letter M, okay, of the Amiga, the M, the first vertical part of the M, you can see it twisting around so that it looks like it's going around the copper bar. This is a very nice trick which used to do with how they used to show rotation, or how they used to show something is rotating on something. Basically what they are saying is, what they are doing is, when it reached that position, shift using BPL con 1, shift the image, okay, on that raster line by 1 pixel, and then they continue to shift it for a certain period of pixels, and then they shift it back. So like that you create that effect of curve of something being shifted around something. that's what it is. And you're going to see, I'm going to show you the code in a minute on the book, because this is a book code. So we did 5, oh god, I've already forgot what was the number. 5D2. 5D2. So there you go. This is 5D2, and as always the same routine. And now all he's doing, okay, so we have the routine that scrolls up and down. Okay, it's the same routine. Don't think anything changed. Okay, nothing changed. What he did is he applied to the copper. Okay, that's what's happening. Register 102 BPL con 1. We are telling it to shift when the image is on when the image arrives on the copper bar. Okay, shift the image by 1 pixel or 2 pixels. Okay, and that's what creates that effect of curve. So there is no routine, it's just a copper list. It's a copper list that we have added to make it look like that. There is no extra code. This is always the same routine that scrolls up and down. Nothing changed there. So you can see how simple and easy all this is in terms of you know, coding and having things on the screen in a certain nice way, let's say that. So the book, so we did 5D. I think we needed to do 5D2. Okay, so we are quite ahead, I think. Now we come to a register, or 2 registers, because for odd and even bit planes it has 2 registers, which is called the modulo. Okay, or modulus, depends how you want to call it, but modulo is the right name. What does the modulo do? Okay, so first of all, the modulo, okay, is register DFF108 and DFF10A, okay, which is called in the Amiga convention BPL1 mod and BPL2 mod. One is for odd bit planes and the other one is for even bit planes. Okay, we were talking about the modulo. Okay, and the modulo is composed of 2 registers, and by default, not by default, you need to set it. I mean, the default way of using it is having 0 in it. Okay, but what happens is quite an interesting thing of how it works, and I'm going to show you a diagram that I prepared. Okay, so this was the previous one, and here I have the diagram that I'm talking about. Okay, so first of all, the default, as I said, is 0. Okay, so this is, again, the one in black is our window. Okay, this is our screen, what we see on the screen. Ignore what I'm showing here for now. Okay, and as I said, this is 40 bytes. Okay, now imagine these lines are here on the top. Okay, just to make things simpler. So this one is the first line, this one is the second line, third line, and fourth line. Okay, and the lines continue to form up our image. Having a modulo of 0, what does modulo say? So basically we read 40 bytes and then we add the modulo. So there's no modulo because it's 0, and then we continue displaying the second line. Okay, but if we change the modulo, we're telling it, okay, we need to skip a certain amount of bytes. So let's say we read the first line, okay, and we tell it to skip, put a modulo of 40. So if we put a modulo of 40, what was we are saying that we need to skip 40 bytes. So this is our first line, line 1 or line 0. Then we tell it, okay, line 0, we arrived at the end of it. We tell it, okay, we have a modulo of 40, so we skip the second line, or line 1, if we start from 0. Once we skip the second line, okay, we do the third line, okay? But we tell it we also have a plus 40 because it's for the whole screen. So we skip the fourth line, and we continue doing this for as long as the screen is long. Now, if we have an image of 256 lines, this becomes 128 lines. It shrinks from the height, okay? What's under the image will be visible at the bottom of the screen, okay? So you need to take care of that. However, this trick was used, okay? When you have an image which is in the far distant, and then you see it coming towards you, okay? And it grows, it grows, it grows. So basically, you can tell, instead of jumping 40 lines, you can tell it, okay, let's jump 80 lines. That means you're jumping 2 lines. So draw the first line, and from line 1, okay, we skip 2 and 3, and we do line 4. So then, when you skip, okay, it even becomes much more smaller, the image, but then as it's approaching towards you, you start decreasing. So instead of plus 80, you do it plus 40, okay? So then it grows, becomes double the image. Imagine a spaceship coming towards you, okay? This is one of the effects that they used. Then imagine the same spaceship coming even more closer, and then to do that, instead of jumping 40, you jump 0 and becomes the full size image. So it will become full size. That is how you get the modulo work, okay? Now we said plus, okay? We said plus 40, plus 80, plus 120 if needs be. So each one of them, we are skipping lines, and we tell how much lines we want to skip each time. The more we skip, the more the image becomes smaller. Now, that is plus. What happens if we say minus 40 instead of plus 40? What will this create? Or what will this do? So if we draw a line, okay, so we draw a line of 40 bytes, but then we say minus 40. What does that mean? We go back and draw the same line on the next line. That's what's going to happen. And we do the same thing on every line. So what happens is that the last line of the image, where we're telling it minus 40, okay, becomes like glued to the screen, let's put it this way, and it creates this effect of melting, okay, which you are going to see, okay. The first example is don't show it, but I'm just going a bit ahead, where you will see when you apply minus 40, it is a melting effect. So what happens is this: we can create an image, okay, that it can be scrolling up and down, and all of a sudden it hits something and it melts, and it's like dropping. I mean, I don't know, like you know, when you paint to the screen, you're painting to a wall with using paint, and then sometimes you have this line that drops down and it continue going down through the wall. That is what happens. It's that you create those lines going down, and that is the effect. That is the effect that we are you achieve by doing -40 instead of +40. I'm going to demonstrate this, but I'm explaining it so that you understand. So just to recap, okay, if we do +40, we skip a line. If we do -40, we draw the last line each time, okay? So default is my modulo of 0, and then you can do either plus or -40 or 80 or something. To skip a certain number of times, the best way to display it in code is to 40, because 40 is one line, times the number of lines that you want to skip. If you want to skip 5 lines, do 40 times 5, let's say. Okay? That's how you can use the modulos. I'm just going to check that I said everything in relation to what I just explained. So okay, so here I'm going to show it to you in the diagram. So we have this image, okay? If we add +40, okay, look what happens. So we draw this line, then we skip the next line, then we draw this line, then we skip this line, then we draw this line, then we skip this line, then we draw this line, then we skip this line, and then we draw this line. And what is after this image gets introduced into our display. So you need to be careful of having like a block times 30 define constant block like what we had before. Okay, how do you program the modulo? I mean, it's simple. In the copper, you just do the register is 108 and 108, and you do 40, which is we're adding 40 here. Okay, here he's showing you if you want to skip 2 lines, do ×2. Okay, that's the only difference. Remember, if you're doing high res, it's not 40, but it's 80. Okay, and now we arrive to example 5ES. So let's show you that. 5ES. So look how the image doesn't make sense, and what's introduced behind it is garbage. In a way, you're seeing garbage, but look at the top, how the image shrinks and then becomes big again. If I had defined a constant block which is so big that allows me to have blank, you will see that I will have blank lines and the image is maybe I can do it. Let's try to do it. Let's see if it allows me to define such a big block. It should. So define constant block dot byte, and I'm going to do 256 times, this is 3. I'm going to do it times 3. So it is 40. 40 is the width times 256 lines, and because it's 3-bit planes, I'm going to do times 3. Let's see if it allows me to allocate so much. Comma $0, 0. And that should be the screen. That should be what's under the image. And let's see what happens. You see, now the image, I don't know why it's doing, but you can see the image shrinking. It's much more clear. That's the mouse pointer that you are seeing. The flicker is the mouse pointer because we are not disabling the sprites. But yeah, that's the image, and you can see the bit planes after it, which you cannot avoid it in this case. You need to do something else, which I'm not going into it. But what's happening is the image up here, okay, this is our image, no, shrinking. But what's happening is the second bit plane is being shown, and here is the third bit plane being shown, shrinked, because of the way it has been programmed. But forget that. It's just I'm showing you how it shrinks. You need to do some other stuff, but yeah. So like that, we have an image that you can see it shrinking. Let's do the code, and the code should be very easy. Let's arrive at 5e. So make it big. So now you can see that he's shrinking actually every 3 frames, I believe. Sorry, every 5 frames. Every 5 frames, he is doing the shrink. And our copper of shrink, I mean, this is the same thing of adding plus or minus 40 on the horizontal scroll, but this time we're applying it on the module. So you can see the same routine used, but this time it's applied on the modulos. Okay, you can see it, mod 1 and mod 2. So where he is applying it. Okay, so this is the same routine that we are used to. If you can compare it line by line with the previous example where he does a horizontal scroll, nothing changes. Yeah, so this is an add. So basically we are adding 40, and because we are continuing to add 40 to the image, it shrinks, no? So that's how he's not shrinking it 2 times or 3 times, he's shrinking it several times. That's why it shrinks to 2 lines, I think, the whole image. But it's the same routine, nothing changes. Okay, as far as I know, let me see if there's a read 5e. No, we are going to do 5f soon. So let's see where we are in the book. So we did that, 5e, and we continue. So here he is going to explain the minus 40, which I just explained, and he's telling us, imagine this is the line, okay, the last line that we draw, okay, and then we tell it minus 40 at a certain point in the couple list. Okay, you will see that this line is drawn on all the lines, the same thing. Imagine this is a drop of paint to a wall, it continues going down, no? And that is what's going to happen. Okay, so with that I'm going to show 5f. Notice what's going to happen. You see the logo is like dropping down, the paint is falling down from it. You have seen this effect several times in the demos. Okay, it's one of those effects that I'm pretty sure you remember, and I'm pretty sure you have enjoyed. Sorry, I just need to, I forgot to enable this stuff on the screen, but you can see what I mean. Okay. So, a nice little demo effect using just the modulus and incrementing or decrementing the, in this case is decrementing by -40, and we create this effect. Let's continue with the book. I'm quite ahead today compared to yesterday. So here he is explaining, okay, the diagram is not maybe so clear, but it's same diagram that I showed. When you add 40, okay, to the line, and when you subtract 40, what happens? He is explaining the add 40, you see, plus 39, which actually, and here is the minus. Okay, he's explaining that, and both effects that I just showed on the screen. Now, the computer is thinking for some reason. There you go. The next example is the example that we will conclude with. Don't run yet, you need to see it and I need to explain it. But this is a typical demo effect that we've seen several times in demos. Okay, so let me show it to you first, then I will explain it. So we are in G. There you go. What we have there is something that you've seen several times now. So we are using the routine to scroll up and down. You know that. Okay. We are using the routine to change the you know, the image on top of the copper bar, okay, to make it look like it's rotating against it, okay. And we are using the effect of the gluing, or when the paint is scrolling down. When both of them merge together, you'll see it falling down, okay. So we are using the same three routines that you've been viewing, but in one demo, and it's quite a nice effect. Let me show it to you without my things on the screen again. Okay, that is the demo that we just created. Simple demo. Of course, what needs to be added is some music, which we will cover later on. So that it does have music, and maybe a scroll at the bottom or something that makes it look better. Okay, of course the image can be also improved. I just, as I said, took an image that I found on the net and I just transformed it because the discs the disk is has got an issue. Okay, let's show you the code for 5G. So we did F, okay, and we are going to do 5G. So it's the usual thing, okay? It's always in it, killing the system, setting the bit plane pointers, waiting for the mouse button, and killing the system. So nothing there. In the middle, there is our routine, move copper, okay? Here is the routine, and you're going to see three routines, as I said. So there is the routine, you should know this, of scrolling up and down, okay? This is the routine scrolling up and down. You can see sub and add, okay? Add 40 and subtract 40, okay? Depending on which direction we are and there's a flag for it. Okay, this is the routine that updates the bit plane pointers, okay, for when we're scrolling the screen. Now, the routine, which I called it routine, for having that effect of wrapping around the copper bar. Okay, it's not actually a routine. Okay, I called it a routine, but it's a routine in the copper list. Okay, you recall what we did is we changed. So this one is the melting effect. Okay, we changed the we change the when it melts, we're changing the copper. Okay, we in the copper we are doing every line. I assume it is every line. Let me check. What's before P07 P3? So every 3 lines. Is it every 3 lines? Every 3 lines. Then P6. Yeah, every 3 lines we are changing the copper. Okay, to do that those lines of like drop falling paint. Okay, and further down, right, I hope I am so let me find. So this is the drop. We are you see, these are the this is the modulo. Okay, this is where we're saying minus 40 on the modulo, and this, remember, it's minus 40 on odd and even bit planes. Okay, so we are repeating this. We are just changing the weight position and then repeating it. You can see, okay, we are repeating that, okay, each time. Okay, and setting colored 0, doing something to, but you can see BPL mode 1 and BPL mode 2. Okay, so it's always that. So now let's find where he's working on the what you call it, the BPL con 1. Where is he working on BPL con 1? So that we have that effect of wrap. Ah, there it is, this one. Sorry, I forgot to highlight it. That's why I am confused. So this one, you can see he added in the middle of it. Okay, so here we are working on the modulo. Okay, and here we are shifting the screen by 1 pixel, here by 2 pixels. Okay, so if we had to check the code, this is what we are going to see actually. Let's check it. So did I not? Hold on. This is the example. Hold on. This is the example without the shift. So do I have? Okay, so I'm just going to, I didn't do it, but I'm going to do it now for you guys. Let me get, I'm just going to do it very quickly. So I'm just going to get visual code. Okay, give me 2 minutes, guys. I'm going to do it for you, so you see what I mean. So now what we need to do, because else you will not see it wrapping up. Okay, so let's read it. It's 5G_1. Okay, you can see now I have Q102 there. Okay, so if I assemble it and I execute it, you will see that it's shifting. Okay, it's rolling over it, and you can tell from the I, you know, because it's straight, letter I of the first Amiga. That is, sorry, I forgot to do that. So I told you it is there, but actually it wasn't. So you can see it shifting. Okay, you can see that. Let's notice the letter I. Okay, you can see it shifting as it moves. That is all. That is all that there is to it in terms of what we are doing. Okay, so just to show you, so just one line, okay, because it's a repetition in the end. We are setting the color, okay, we are setting the shift, okay, BPL con 1. We are telling it that the drop, you know, the lines of that's dropping is -40, so that we see the last line drawn. Okay, and this is for odd and even bit planes. And then we wait and we draw the next we draw the next line, and we are doing this every so 7, this was F, okay, and we are doing D, so every 3 lines. Okay, D, so now it should be A, and there you go, it's A. Now it should be A, and then it's actually it's not every 3 lines. It depends on the raster bar how it is. So then we do 5, so we jump 5 here, and then we do D, so we jump even more, and we continue doing that. But this is the effect of wrapping the code on top of the, not the code, the image on top of the copper bar. So if we run the first one, okay, just in case you have doubts, you will see that doesn't wrap, it doesn't bend, you know, the Amiga on top of the copper bar. Okay, it's the A. Okay, I'm just going, let's show you again. I'm just going to, you see, this is a straight line of the A. It's not bending, it's always the same. Now if we run GS_G1, where we are including the BPL con 1, okay, you should see the A. You see it bending, you see it, it's not straight. You see it bending here. Okay, that gives it the effect it's wrapping around. Okay, that's basically it for this example. We have arrived to the end. Thank you very much.